Good afternoon. Hello, take your seat. Thank you for joining. I'm very pleased today to be here with you at Indetech 2022. It's really a privilege because we saw already this morning how important this conference is for the European Commission, for the country who is having the European presidency until end of June, France, and as well for the community of researchers, the community of institutes for innovative solutions, the industries as well. So we had this morning a lot of presentations about how policies can bring innovation in industry. This afternoon we will go in more concrete examples. And I'm very happy to have you here for our green manufacturing session. So a few years ago, when we were talking about green manufacturing, it was just a question of good waste management, good resource stewardship in factories. It was as well, how can we put solar panels on the top and then we will be green? But today, it became an urgent topic that manufacturing is changing and shifting. Today, green manufacturing should be circular. It should be low carbon, and it should be sustainable in all its aspects. So it creates a lot of complexity. I'm here with experts from the industry and from the university, and we will dig into what the European Green Deal is bringing to us in terms of roadmap and the conditions for moving away from the linear take, make, use, dispose model and the transition towards a circular economy. How to keep value of products and resource in the economy as long as possible and minimize the use of resource and the generation of waste. The green manufacturing development should meet as well the need for new production systems. It's a change of paradigm we are used to here. And it's important as well to not to underestimate the change it requires in industry, in mindset, in connection, in collaboration to succeed in transitioning towards a circular economy. This section will explore examples of circular economy initiatives and technologies supporting the transition of our value chains, sometimes very complex. So from transforming the manufacturing systems to innovative solutions for making waste become resource. Some best practice will be shared across different innovation markets, and recommendation as well will be proposed for implementing them. I will call my first speaker. My first speaker is from Grenoble, Mrs. Peggy Zolinsky. So Mrs. Peggy Zolinsky has track records of research, investigation in eco-design. She is Deputy Director of the G-Scoop Laboratory in Grenoble, and she has witnessed the evolution of eco-design to circular economy. She knows a lot about industrial systems, and she will tell us what journey it represents and what it needs to be done for companies and for ecosystem of industry to really become circular. Peggy.
Okay, thank you very much, Myriam. Thank you. I just put my glasses, sorry. So yes, as you said, I've been working in research for more than 20 years, and I'm developing methods and tools to help companies to reduce their environmental impact. In this presentation, I will focus on circular industrial systems, which could be very interesting systems to contribute to green manufacturing. So I'm working in the G-Scoop laboratory here in Grenoble. This laboratory is interested in production systems. In this lab, we develop researches on supply chain, logistics, task planification, and we use for this operational research and optimization techniques. We also develop models and simulation for the management and control of production systems. So we have many activities about how to realize the product. But we also have some activities dedicated to design. So how to design the offer, and as we conduct then researches about method and tools to support collaboration between designers with collaborative tools. We work on the integration of life cycle experts into the design phase, and we try to develop model and simulation to support the product development. So all today, most of the approaches we have in our laboratory try to are put in place to propose to allow companies to better address various transitions. So at this time we have the transition about the ecological transition, the digital transition, and what we call in France industry for the future, which are the three main transitions that companies have to address at this time, mainly in Europe. In order to calculate or to assess the impact of production systems, because we try to decrease the impact of production systems, we are used to consider the entire life cycle of the solution under study, and with the extended producer responsibility, we are more and more looking at different scenarios like recycling, remanufacturing, reuse, but also new businesses like product service system, which are a new solution to try also to share and decrease the environmental impact of our product or activities. In theory, it is said that those different scenarios are useful to keep the value of product, materials, and resources in the loop, to maintain it in the economy as long as possible. So this is in theory. In practice, to do this, we need to consider the new productive system with a systemic approach, taking into account both human, environment, and technologies. Okay, so this is for the context. So when I will talk about recycling, and recycling for me is a transformation of used products into raw material, and remanufacturing is a transformation of used products into new products. Those two scenarios are very well developed today, more or less, but they have just one default, is that they don't satisfy some consumer who would like new functions or new things on new specificities on their product. So we need to create a new circular economy scenarios. So the first one could be the upgrading. So it is also a well-known scenarios with the example of the photocopier. In this upgrading scenario, in fact, we transform used products while increasing their performances or functions. So this means that for any use cycle, with an upgrading scenario, you just have to add a little bit of material and energy to obtain those end use cycle. Another scenario which can be really interesting for us is repurposing. With the repurposing, we transform used product for another different second use. So I take the example of the electric vehicle batteries that can be transformed into a stationary battery to be able to store energy for stationary application. So in that case, the repurposing scenario is really interesting because you design and you manufacture only one product for two different uses. Okay, so the context is done. The question now is why are we looking specifically at those circular scenarios? The concept is really easy. You just have to take used product and put them into the remanufacturing process, but it's not so easy. Why is it not so easy? The first thing is that you have the first difference is coming from the fact that used products are distributed and they belong to consumer. So it's really not easy to put in place the reverse logistic to obtain this material and to do something else with this material. So the distribution of this raw material is not easy to manage. Then we need for this collection to create new networks, so new organization in favor of the recollection. Because of this situation, we have we know that the quality of used product is not well known because it depends on how the consumer used previously the product. And the quantity of used product is variable because you never know when the consumer is able to give it back to you during the lifetime of the product. So because of this, we know that in a closed loop, in a circular industrial system, manufacturing processes must be really agile to be able to manage the variation in quality and quantities. Above this, we know also that when you buy a single material to process it for a new product, you know more or less the quality of your material. In that case, in the case of circular production system, you need to, before manufacturing operation, you need to make a kind of diagnosis to make sure that you are able to transform your raw material. Last point, perhaps the tricky one, is that the circular industrial system cannot compete directly with a classical linear production system because in those linear production systems, usually the performance is predefined on quality, cost, and delay. More and more with you consider environmental indicators, but it's not so well established. So if you want to assess the performance of a circular production system, you have to emphasize a little bit more on new indicators like environmental indicators and social indicators. Okay, so because of those differences, we state in our research, we say that it's necessary to design a new industrial system specific to support circular scenarios. So we try to start researches to develop knowledge, tools, and methods to help companies to be able to create those new industrial systems able to transform post-use products into a brand new product. This raises many questions, so you have some of them. How to do with legal condition, the status of waste, economical condition, is it worth or not to go on this? We have troubles with skills and competencies on the operative line. We need to establish new diagnosis and prognostics on product. How about consumers and workers' acceptation, etc., etc., etc. To start answer those questions, we rely on the circular project that I will present here, which is a project funded by Grenoble IDEX, a local funding, and which brings together more than 80 researchers from different disciplines with engineering sciences, computer sciences, human and social sciences. 12 research teams are involved in this project, as well as 3 technological platforms to develop different solutions with a total budget of 2.1 million euros. The objective of this project we have two main objectives. So the first one is to develop the condition for the existence of these circular industrial systems, and also to make effective the transition to those circular industrial systems. We did some project hypotheses, having a look on different case studies. So the first hypothesis is that if we want to be able to make it real, we probably need to focus on how to obtain a responsible and acceptable human-machine collaboration, because we need the human in the loop to have a system which is sufficiently agile to address all the variation we have already stated before. It's probably the main lever to obtain a kind of upscaling of this kind of circular economy systems. Our second hypothesis, but I already explained it a little bit, we think that the industrial processes and their environment have to be systematically redesigned to adapt the new input, because it's really hard to integrate circular economy into linear processes. And the last hypothesis we did in this project, and this is the reason why we had people working with us on the legislation analysis and condition analysis, is that we think that the massive deployment of the solution needs specific incentives and industrial conditions, because in most of the cases we have circular industrial systems coming from scratch, raising from scratch. So we need some incentive to help the company who want to switch to those kind of solution. Okay, so in this project, 5 main challenges were implemented. The first one is dedicated to the incorporation of 4.0 technologies in the context of circular economy. For example, we have defined guidelines to the proper use of cobotics in circular system, and we try to develop methods to adapt cobots to industrial and human variation. We also have technological results in this project concerning human cobot safety, with the development of anti-collision algorithm based on low-cost sensors. The second challenge we have in this project focuses on diagnostic and prognosis, because we need, before managing the used product on the productive line, we need to know the state of health. And for this, we have to combine PHM and CBM approaches, which means, I would say, physical modeling of the product and also information coming from intelligence artificial data to make sure that the used product is candidate for remanufacturing, upgrading, or repurposing. In specific cases, at this stage, we had to develop specific test benches, like for electric vehicle batteries, because there was a lack of data. The third challenge is about the measure of the performance of circular industrial system. I already told a little bit about it. We have to add environmental indicators as well as social indicators. So we had to measure this performance. We try as much as possible, for example, to measure the environmental impact when we try to implement 4.0 solutions. The next challenge is about the management of those circular value chains at the territory scale. So territory scale means geographical territory or industrial territory. In that case, we have to monitor product components, their availability, conditions, etc. And for example, new solutions as urban factories are considered in this project. And to support the transition to new circular industrial scenario, we have people from human sciences looking at how were developed the different producer responsibilities in the past, and to try to see if with those new circular economy action plan or new AGEC law, we are able to reproduce what was done in a previous extended responsibility. So as a conclusion, circular economy is becoming popular. It reinforces existing scenarios. We create new scenarios. We have to support new industrial systems with as much modeling as possible, as much information as possible. The agility of such kind of system is really important. We really have to create agile systems and to keep the human in the loop to make it possible. Whatever will be the solution we will develop, they will serve all the circular economy scenarios. So go on, just continue. And the last point is that the question of the industrial performance of such system remains tricky because we are looking at complex organization and with more and more criteria to consider in the system. Thank you.
Thank you, Peggy. I invite you to take a seat for the panel discussion in a few minutes. So now we have set the scene on circular economy, and as I mentioned, it is very complex, and it's not enough to be circular. We need as well to address the objective of the European Commission to become carbon neutral by 2050. So what does it mean for our supply chains? Should we decarbonize them? And what does it imply for the collaboration within the supply chain? Does it change the relationship with our suppliers, our customers, and how to capitalize on improvement along a supply chain which is beyond the fences of our factories, of our territories, and that requires some tools. So to be very concrete, I'm calling now Martin Chilcott. Martin Chilcott is the CEO of Manufacture 2030, which I would call the service provider to help communities of suppliers and their customers to set targets and to consolidate them to reach ambitious carbon reductions. The floor is yours.
Thank you, Miriam. That sounds good. Hello, everybody, and welcome. I'm going to talk about the relationship between decarbonisation and the circular economy. The fact that when large organisations set themselves decarbonisations, emissions reductions targets for their supply chains, they're not really talking about, or they shouldn't be talking about decarbonising their supply chain today. They're really talking about transforming their supply chains to be decarbonised at some point in the future, 2035, 2040, whatever their target date is. And that this process of decarbonisation is not about just incremental improvements in efficiency, but leads to radical transformation. And part of that radical transformation needs to be how we incorporate circularity as part of it. One other thing I want to address as we're doing this is the need to make this transformation in stages that enable us and enable suppliers to build momentum. That we have a little bit of I was talking to some other delegates earlier about this, so forgive me if I repeat myself, Patricia and others, but we have a little bit of a preoccupation in industry, particularly in Europe, thinking that we must get perfect data before we can drive change. And in fact, data is absolutely essential to what we do, and it's an essential part of my business, but equally essential is building habits of change and momentum towards change. And so actually the most important thing that we can do within our supply chains is to start that engagement and to start making progress and start building new habits. So as a business, we're focused on this mission. It's the challenge of our time, the challenge of our generation. There is nothing that is more difficult, more important for us to achieve than to address climate change. But what is often understated and under-recognized, that this is perhaps the biggest economic opportunity that we've ever faced. If we think the internet was a big economic opportunity and a major revolution in the way that we were going to produce and consume, then moving to a sustainable system is going to be even bigger. So we need to think of this not just in terms of a challenge, it's not just in terms of an extra cost or as about risk management. We have to embrace this as an opportunity, and an opportunity for companies at the top of supply chains and at every stage within those supply chains. We work with at the moment, about 20 major global corporations and their manufacturing supply chains around the world. 50 countries. The figures in the middle there are slightly out of date. I think we're close to 5,000 manufacturing sites around the globe. And we are working with them to create value that is shared both from the supply chain owner and the supplier, that they're working together in a collaborative ecosystem, supplier to supplier, supplier to customer, customer to customer, in order to create value for all of them. And we talk about the need to move supply chains from regarding addressing climate change as a cost of doing business. So very often we have systems that require, people who require data from their suppliers, and this is seen as a cost of doing business. We've got to move from that paradigm to one that says this is about actually transforming our supply chains and value chains so they are future fit, and fit for being sustainable well into the 21st century. We work by capturing data, using that data to manage the supply chains, and then supporting the suppliers to actually reduce their emissions. The type of data we capture is in two sorts, and it's the second sort that is most important to what we're going to be talking about today. So, of course, we collect data on the carbon footprint of the suppliers, and we collect it at a manufacturing site level, Scope 1, Scope 2, and the suppliers, Scope 3. But more importantly, we get the suppliers to build a climate action program, which is their glide path to go from where they are today to where they need to be in order to help achieve their customers' target. So imagine you start up here, your carbon footprinting of your own as a supplier, Scope 1, 2, and 3 says my carbon footprint is up here, and I need to be reducing, let's say, at about 3% per annum in line with science-based targets, because I'm a customer to a Honda or a Ford, and I need to be down here by 2035. So is it better without this microphone? Okay. That's somebody else. And you can imagine that they build this plan, and the plan generates a series of waterfall reductions over time. And so you can see exactly what these suppliers have to do in order to get down to that reduction target. And that means that we can look across these 5,000 manufacturing sites and we can see exactly how many are looking at compressed air leak inspection programs, how many are going to change out their boilers, how many are going to do on-site renewables, how many need to address the embedded carbon footprint in the materials that are going into their factories, and how many of them are producing waste, industrial waste materials that need to be recycled or reused or remanufactured in some way. That data at that scale gives us unprecedented insight into what the market needs and therefore what is possible. And I'm going to give some examples of this just to really bring it to life. But we can identify action in order to hit a target, we can coordinate demand, we can aggregate demand to signal to the market that it is worth making investments in certain areas because there is going to be demand and need for new ways of operating, new products. And this particularly applies to recycled materials. So here's just some statistics that came out of 2 years with one of our grocery clients. I think it's about 600, something like that, food and drink manufacturing sites that serve at the UK retail Asda. And you can see the kind of scale of reduction that you get when you have this systematic approach to reducing carbon. But interestingly, bottom right there, you can also see the amount of materials that get tracked in a process like this, which open up the possibilities and the questions of how could we do this more sustainably and in a more circular way. 905 million tons of material inputs tracked for Scope 3 by these 600 manufacturing sites that can be transformed by a circular approach, and their carbon footprint can be transformed by it. So let me give you a couple of examples. I'm going to take the humble egg, if I may, because everybody knows what an egg is. If I spoke about what's happening in our car industry with EV batteries, we'd all understand that a massive transformation is taking place to cars, that we're moving away from cars to a concept called mobility. But let's just take the egg, because the egg is so simple. Morrison's, one of our retailers, did a carbon footprint of the egg. And then they found that the footprint of the egg was in the feed for the chickens. Chicken feed. Why? Because industrial scale egg production requires industrial scale chicken feed, and that tends to be soya. And we all know the problems that soya has. So there's the problem. So initially they said, okay, we must decarbonize that. We've got to find lower carbon soya to buy. Can we go out and talk to the round table for sustainable soya? Can we find some other way of doing this? And then some smart person said, actually, no, we're looking at this the wrong way. We shouldn't be looking at just getting lower carbon soya. We should be looking at some other problems that we have and how this could solve those other problems. And they said, well, actually, about a third of the food that we produce and sell is wasted. Can we take that food waste, which is a massive problem for us, and feed it into these insect farms that I've come across, these industrial scale insect farms, and can we harvest the insects and turn those into high quality, low carbon, zero carbon, high protein chicken feed? And that's exactly what they've done. So they've taken the common egg, and they haven't decarbonized the supply chain. They've transformed the supply chain in order to find a way to reduce the carbon in it. And their way to doing that was circularity. And the key there was to be able to identify and spot other areas of challenge, in this case food waste, that they could leverage in order to make that change. So what's really interesting about these kinds of circular responses to a decarbonisation challenge is they're not immediately obvious. They come out of the data that you collect. The other one I've got up there is tomatoes. There's a tomato producer in the north of England that's hugely successful, so successful now that they've bought enormous amounts of greenhouses all over Spain and grow loads of tomatoes all over Spain. But before they did that, they competed perfectly effectively with the Spanish tomato growers. And they did this because the owner of the farm had a fascination with sustainability and wanted to reduce the carbon used to produce the tomatoes in the greenhouses. And he started off by creating, he almost purpose-built for himself, a double-stomach biodidigester to digest the green stalks in the tomato production. And they digest it down, and they use that process to produce gas, and they burn off the gas to produce the electricity. They capture the carbon dioxide that's produced in that process, and they pump that back into the greenhouses. So they started off by looking at decarbonising the process of electricity generation for the lighting and heating of the greenhouses. And they ended up with a biofuel. They've ended up with 40% bigger tomatoes because of all the carbon they pump into the greenhouses, it gets absorbed. They've ended up with a fuel. So at one point they had their trucks driving around the UK saying, they were Tesco trucks. It said powered by tomatoes on the side of their trucks as they drove around. They used the biofuel for their trucks. And of course they used the digest from the anaerobic process as fertilizer with the tomatoes. So it starts off as a kind of a point challenge. How do I decarbonize my tomatoes? And it ends up with a highly creative, entirely new way of operating, which creates all sorts of offshoots of reusable, recyclable products, which transforms their business. So I just thought I'd give you those two examples to show you just how creative a process this is, but it is utterly dependent on having the right data to give you the insights that you need, and it is totally aligned with trying to decarbonize supply chains. Thank you very much indeed.
Thank you, Martin. I missed to remind you that you can use Slido for logging your questions for our speakers and for the panel discussion that will come in few moments. What does it mean as a transformation to become circular for a big company in the chemical industry? I'm calling François Laurent. He is the CEO of Covestro in France, and he will explain how much work it takes, how much ambition it is to become circular and more.
Sorry. Good afternoon to everyone. A warm welcome also to all people who will watch this session afterwards with streaming. So I'm very pleased, and it's really an honor for me to have the opportunity this afternoon to share with you what is going on, what does it mean at Covestro, the march towards circular economy and keeping, of course, an eye on sustainability. So you might try to understand who is Covestro. Covestro is an innovation-driven company active in the production of premium technopolymers with a long life cycle. So we are far away of the so-called single-use plastics. This is a big company. We have a look on the left hand of this slide about some key figures with sales approaching 16 billion euros last year and almost 18,000 employees. We have a network in the range of 50 production sites worldwide, and thereof approximately 18 in Europe. Innovation, so we pretend to be innovative with a staff around 1,500 employees in the world, acting, of course, in a network and very open to the external world. I will elaborate a bit later on. And innovation is not less, not more than a crucial part of our DNA for decades. So the mission of Covestro is to make the world a bright place. And about 2 years ago, the board of management becoming more and more aware of the need to really fight and to be a front runner in terms of measures and of new policy to contribute to the fight against climate change, because I think also all of you also will share the opinion that there is no other way around. We cannot stay and wait, and despite some uncertainties, including what has happened in Europe right now since the beginning of this year with a war in the eastern part of Europe, we have still to accelerate. And therefore, besides the commitment in principle to become fully circular 2 years ago, we have released a couple of months ago our targets with very clear milestone, and it's to become fully circular, to become carbon neutral in 2035 for the Scope 1 and Scope 2. One specificity I like to stress here, facing this audience, is that it's not a story of only the board of the upper management of the company. It's embedded in all employees' daily life. And just as an example, the global bonus system will have, as of this year, a fourth component taking care and taking into account our performance in terms of reduction of carbon footprint. So, as already mentioned, the intention, the ambition is to be a front runner, whereas in lots of cases, other players in the chemical industry aim to become circular only as of 2050. We want to be faster, we want to be more efficient, and just as a matter of fact, the commitment consists in becoming with net zero carbon footprint in 2030 35 with a very important interim milestone in 2030 with a reduction of, by already 60% in comparison with 2020. So with that, with this package also, we want to stick to the Paris Climate Agreement, COP21, 6 years ago, to limit the warming on the planet by only, between inverted commas, of course, 1.5 degrees. How we will reach this ambitious goal? We want to rely on 4 pillars, 4 crucial action areas. And the first one is to use alternative raw materials. The second one is to move onwards to innovative recycling, because we are fully aware, and some of you for sure also likely, there is a big limitation to rely only on mechanical recycling. And as we are from background and from culture in the company, we are chemists, we want to innovate also in recycling, and we have also positive track records in that area. We want to rely on joint solution. The time is over where only one company could pretend also to have the full knowledge about a very complex topic, and we are involved in lots of joint projects in cooperation, wherever with customers, with research institute, with universities, and regardless of the nationality. Covestro is headquartered in Germany, but we act globally, and there are lots of projects. And starting with Europe, we have had some projects with up to 8 or 10 different countries involved in the same project, and a very wide set of participants. And last but not least, also we want also to say goodbye to fossil energy sources, and to use and to switch on renewable energy sources. So first area, alternative sources, alternative raw materials. Biomass, we have already more than 10 products commercialized with bio-based feedstock, and we have almost 30 running research and development projects. One very important remark: we don't want to make a competition between biomass feedstock for the production of polymers against human food. Also feeding people has definitely the priority, and this is also our commitment, that we won't mistake the goal. CO2, carbon dioxide, it's a kind of paradox. As it was started, this program, around about 13 years ago, it was really a dream. And the project name, the project code of this development was Dream Production, because at that time almost nobody was able to become convinced it was possible to use CO2 as a complementary feedstock to produce virgin product. And we have already a production facility in Germany, close to Cologne, producing in the range of 6,000 metric tons a year of long-chain polyol. And last but not least, also, we intend also to use end-of-life materials, so waste, and I will elaborate about this later on. So, products made of plant biomass. Some concrete example for the automotive industry where we are in. We have cooperation with 2 companies, with a coating German coating company and automotive producer, namely Audi, and this is already a big progress. We have also application in the leisure and sports area, and also for healthcare and personal identification, RFID. So we have also in the pipeline, and we have already a patent for that, to produce aniline. We demonstrated we are able to use plants to produce this very key precursor, and which is needed, for instance, in the polyurethane industry to produce rigid foam for building insulation, for instance. Innovative recycling. So we are convinced that the waste is a very important resource, and instead of putting that on the ground or to burn it out, we think also this is a very positive source of making the feedstock set up differently. So we have already some achievements in that area. We want also to develop new solutions for plastic recycling, and we have, regarding polyurethane foam, already big projects, and we have proof of evidence that we are able to recycle completely old mattresses, old pieces of furniture, upholstery, etc. And I'm pleased that we stay here in France. I'm pleased that we made public a partnership in November last year with a French eco-organism appointed by the government, namely Ecomobilier, and we have signed with them a joint business plan for the next years to come, dealing with different topics. I cannot elaborate here, unfortunately, because there are several NDAs in place, but you'll see in due time what was about. We have, as already mentioned, different projects, and I can elaborate later on in case of a question. And the aim is also to be open and to cooperate with the European Union and at this regional level to recover with the help and the input of customers, of different partners. The aim is to recover up to 90% of the used polyurethane to create building blocks. Joint solution, I already mentioned that. Also, we want to cooperate in a very open manner, as efficient as possible, and basically there is no taboo at Covestro. Also, we have a kind of internal buzzword. Instead of to say, oh, it won't be possible, the first answer should be, why not? And we like to challenge the status quo, and we are really in that mindset to work on recycling and circular economy topics. So you are probably aware of that. Also, we were at the very beginning a member of the Alliance to End Plastic Waste, and we contribute in different manner also in the European Union Circular Plastics Alliance, and we want really to be a front runner. Last but not least, energy. Goodbye to fossil energy sources. So we want, and we have already achieved, to reduce our consumption of electricity, of energy, generally speaking, for producing our materials. Renewable electricity. So we have in place a contract, for instance, with Ørsted from Scandinavia. And as of 2025, we will have a strong contribution from them for the electricity consumption for our plants in Germany, where we have a big production network. Solar energy is also an option, and also renewable steam will be a key factor to reduce our carbon footprint in the next future to come. So the time has been flying. It has been a pleasure. Thank you for your attention.
Thank you very much, François. So our journey towards circular economy started at the university with Peggy. Then we went to how to build the tools to extend, to address the supply chain, to collect data, and to show the progress. We saw as well how much ambition it takes to a large company to take this journey on and to start the shift. But what does it make when a complete society coming from waste is becoming something else? I think there is no better introduction to what you will be telling us, Lars and Per Larsen. Per Larsen is from Ragn-Sells, a Nordic waste company from Sweden, operating in Scandinavia. But you have new stories to tell.
Thank you so much for that introduction. And yes, Ragn-Sells, we are a waste management company. And to be honest, for 7 years ago, when we did the forecast for the future, and when we looked into the future of the circular economy, we understood that there is no place for a waste management company. Then we understood we need to transform, we need to change, we need to understand what will our role become in the future of the circular economy. One of the things we looked at was, of course, the planetary boundaries. We can support the society with solutions that will minimize the risk that we overshoot any of those. We might have a business possibility. And to be honest, we started really back in the future. By the way, I was hired by Ragn-Sells in 2015, and before that I worked for more than 25 years in the food sector. And I developed a program how you can change, if you can change the consumer's behavior, if they will, because I work for the burger business and we served beef burgers, and we understood then back in 2005 that the society would like to have low carbon emissions products. And we truly understood then that the CO2 emissions from that company that I worked for then, the mainly was based on the beef in itself. So what we did was we did the carbon labeling scheme that the consumers then could pick, should I eat a beef burger today with a 3.1 kilogram of emissions, or should I take a vegetarian one? In 2009, when the COP15 was initiated in Copenhagen, I was invited just a couple of weeks before the conference to come down and do a keynote. And I was traveling around the world talking about our solutions back then. And I asked, how long can I speak? And they said, please make it just in 1 minute. 1 minute? Well, it's you, it's Tony Blair and Gro Harlem Brundtland. Okay, I take my 1 minute. One other person that also was given 1 minute was Professor Johan Rockström. And I didn't have a clue who that guy was. But that was when he presented also the theory behind the 9 planetary boundaries. Ragn-Sells, we are a waste management company. We're originally from 1881 when we were a transport company, transporting goods and people with horses. In the 1960s, our focus became 100% on waste management, and today we're a recycler in today's linear economy. Already back in the 1880s, we started bringing back latrines from the inner city of Stockholm to the suburbs, or to the farmlands producing the food for the city of Stockholm. Today, nutrients, phosphorus and nitrogen are a key component in our business development. And we have developed solutions that will minimize the risk that we overshoot this. And now we not talk about geographies about the Nordic countries. Here we talk about the global potential. But of course, all other planetary boundaries are also key in our business development. As well as when we understood that the huge impact, if we can create circular material flows, what will have on the CO2 emissions. Just give a picture of what the problem is. Today we are wasting a lot of waste. Everybody agrees. And this is the numbers in Sweden. And here we have both the household waste as well as house waste from construction sector or from any waste that we call this waste. The thing is that society tends to focusing on how to minimize the waste instead of understanding that it's the input where we have the biggest emissions. We talked about the egg before. There's the same thing. It is the input when you produce things that normally has the biggest input. So therefore, I really would recommend to have the policymakers to stop focusing on minimizing the waste. Let's make sure that we can bring back the resources and replace with other things. I will give you some concrete examples. Here we talk about the future. We know already now how much more resources we want going forward. And I will just take one of those elements. I will take copper. We know that we need to dig up every gram of copper we have in our mines if we're going to replace today's fossil energy with electric-driven cars or electric-driven processes. And it will not even last. We need to have more. So the only way forward, if we would like to go fossil-free, is to make sure that we create circular loops. Today, it's called recycling if I landscape with material containing a lot of copper. Or if I construct a road I don't need. It's also called recycling. It should not be allowed in the future. I'm really happy that EU has been also targeting specific resources. And the last update was in 2020 when 4 new materials were added. 1 were taken away. The new materials was about battery metals primarily. The thing is that we have more and more tend to say that the need are focusing on Wi-Fi, not maybe on food. The hierarchy of need, the Maslow hierarchy of need has not been taken care of until this year. Because what's happening now is that we understood that we need to also produce enough food for the world. EU has already said that phosphorus is important, so phosphorus is two of these critical raw materials, but we need really to go from talking to action. And this has been a core of the understanding now due to the Ukrainian crisis and the challenge to get wheat. But this is just a glimpse of the problem that will happen in the next decade. We will face huge problems. Ragn-Sells, what we have done, we have developed solutions that are based on 3 principles. We need to make sure that the solutions bring back resources that we can reduce the need of virgin production somewhere else. Secondly, we need to make sure that we decontaminate. We can't loop back everything. We need to take out the unwanted things. And thirdly, we need to make sure it doesn't create any problems for future generations. Here we talk about the climate issue, but also other all environmental issues as well. And one example of those processes is how we are producing potassium out of fly ashes. After waste incineration, you create a lot of bottom ash that contains copper, and then you have the fly ashes that until now has been landfilled or in some cases used in constructions. But we can extract the salts that has 90% lower CO2 emissions than today's mined salts. And the most valuable resources and most important resource here is the potassium. And the first factory will be up and running from, I think, November this year, is already in commission. And we already now are planning for the next plant. Another example now, and here I will talk about a new way of finding a new mine. And here we talk about our wastewater treatment plants. We have for long understood that the huge potential to extract more resources out of the wastewater, and our specialty, of course, phosphorus and nitrogen. And I've been addressing this both on the UN level as well to the World Trade Organization. And in 2009, I held the first speech in Geneva. And after my speech, the chairman said, "Thank you, Mr. Larssons, but sorry, circular economy for us is to make sure that we fulfill the agreements in the Basel Convention. Don't spread hazardous waste." This year in May, I was invited back again, and my main message was make sure that we create free trade for resources that we are really dependent on as phosphorus. After this speech, they said, well, now we understand that waste can be a resource, and yes, we will need to focusing on creating and enable this thing to happen. So even World Trade Organizations have now started a program to make sure that we can enable circular material flows, which I'm very happy of. Let's now dig into the mine, that the more we use this mine, the better it will be for the planet, the better it will be for our health, and the better it will be for our future generations. And that's our wastewater treatment plants. We have developed processes that can extract resources. And what we are especially see, the most important resources here is phosphorus. And to be honest, we have 50% of the need in Europe can be replaced by using recycled origins. And today, just 10% are produced within Europe, and that's from a mine in the northern part of Finland, and that can be replaced. Our process means that we, after incineration of sewage sludge or any other raw material containing phosphorus, we can then extract and separate the different resources. And the phosphorus, of course, is the most valuable, and the quality that we are producing has the same quality as a feed phosphate. It is even better than any other raw material input that today is offered to the market. So your egg producer in the future will be able to have phosphorus instead of soya. We can have recycled phosphorus with a much lower CO2 input as well. But the good thing is that we can separate all the other things as well. So there's from 100% waste today, or even eutrophication, we create zero waste. We even reuse the heavy metals. The copper will become new copper cables. The only challenge, though, is that regulation says no, we're not allowed, because it's not quality that sets the rule in Europe. It is the origin. And for 2 weeks ago, this report was published about our phosphorus future, talking about the importance of recycled phosphorus and use the resources that we already have taken up from 40 scientists across the world, a work that has been going on for 5 years. So things are happening, and we know that Europe, EU are really on it, but we need to quicken up the process. The third example, before I end with a very good example how a French company are really dedicated to creating circular material flows and are really able to do that by collaboration, because collaboration is a key factor. That's our Natrium solution. And what we do is that we can replace part of today's process, the Haber-Bosch process, with a new way of extracting Natrium directly from the wastewater. And we talk about a chemical circular process where the Natrium are catched in one part and then released in the other one. And we directly will produce a Natrium fertilizer. It will reduce the cost for society, because it will be lower cost than today's conventional methods, and there will be no laughing gas emissions. I would like now to end with the last session, and here we talk about a concrete example how we are using carbon dioxide as an input to produce new raw materials, exactly as Covestro are now developing different solutions. So let us see a small film about the project.
You don't have to believe in climate change. You only have to know that all your partners, trading partners, the ones with whom you trade in services as well, they simply will not buy goods and services which are produced not in a clean way.
We have a saying, those who are late will get nothing. We don't want to be left behind. We want to find Estonian niche where we could be strong, where we could be number one in the world.
This ultra pure and carbon neutral calcium carbonate are produced of old shale ash remains after electricity production.
What is very nice is that we are using two waste streams, the ash and the calcium from it, and also CO2. And we put them together and we have a fantastic product for the market. Something that is used in everyday items, calcium carbonate.
This is precisely the purpose of Ragn-Sells project, turning the old heaps of oil shale ash into a useful chemical component with captured CO2. It is a great example of carbon circularity.
So we are turning what today has been stockpiled since the 1960s. It's in total 600 million tons of ashes that are placed in these ash mountains, and we can produce 200 years of cement production or limestone that are needed in the cement production. That's the equality of the size in the total. Or in total, we can reduce the CO2 emissions with 400 million tons. That's 8 times as much as CO2 as Sweden as a nation emits. But we can't do that by ourselves. We need partners. And the primary partner that we are working with is Tarkett, the French company, the flooring company, that understood the importance to reduce their CO2 emissions. Can't be done by just reducing the emissions directly at the factories. They need to source differently, and therefore we're very glad with the collaboration to create this partnership. The biggest problem we have is not that we have buyers or partners that would like to buy the calcium carbonate. It is one of the raw material inputs, and that is the CO2. We don't know if we can have access to carbon dioxide, because today's regulation says, well, in Europe says you need to store it for at least 100 years. I was very happy though just a month ago when Frans Timmermans' cabinet called us, and they wanted to come and visit our facility and talk to us about our challenges. And after 20 minutes he stood up and in front of the Estonian TV he said, I will make sure that this project has CO2. But you know, he's a politician, so we need to remind him for 10 times. But it looks promising. These are 4 examples of innovations that we transformed our company from a player in the Nordic countries to become a global player. Both our phosphorus and nitrogen innovation have already been of high interest from cities as New York or cities as Singapore. But we will not go there. We'll start in Europe first. And of course, here we need more partnership and more partners going forward. So by that, I say thank you so much.
Thank you, Pa. So, do we have some questions on Slido? Oh, thank you. So, reverse logistics. Could you please discuss the requirements, conditions to be in place for successful recovering, reclaiming of used products for repurposing? Peggy, would you take the question?
Yes, sure. But it depends on the product. Yeah. In fact, I have to answer about this question. Two things are coming to my mind. The first one is that we were working a lot about considering electric vehicle batteries. And in this specific example, we discovered that for the reverse logistics supply chain, we needed some new actors in the supply chain, because it's like the wine. If you want to keep a battery with a good state of health, you need to recharge it. So you need a specific operator to store your batteries and to be able to maintain it in good condition while plugging it. So that's the first thing. The second thing is that we know that in circular industrial system there is a win-win approach, which is selling services instead of the product itself. So in that case, as a producer, you keep the property of the product. So it's really it's more easy to in that case to organize by yourself the reverse logistics. So the product is still distributed to consumer, but you have the property of this product. So it's easier to decide when you want to recover it and when you, because in some cases you need a product with good conditions. So I have another example in head. We were working with Volvo trucks, and when you have a specific particle filters, if they are too used too much, there is a degradation of those particle filters. So it's better to recover them before to have the reverse logistic before. It's the same for truck tires. So if you own the product, it's better for you to control when the reverse logistic is good to be put in place. I hope I answer a little bit to this question.
Thank you, Peggy. There is a question about the bioplastic tomato clips that can go to the waste.
Certainly. I don't think it's so much a question. I think it's a statement from somebody who sells bioplastics in the audience, actually. They're absolutely right. Yeah, if it's a compostable bioplastic, it wouldn't need sorting, which is obviously a good thing.
Thank you. Before we go to the third question in Slido, I have a question to François. François, you didn't address the scope 3 in your objective, and for those who know what are the scope 1 and 2, the energy used and the source of electricity and to power the plants, that's the basic of your commitment right now. What about the scope 3, which is something that a lot of companies are already addressing?
Thanks for the question, Miriam. Actually, you're right. Also, it's very important. At Covestro, also, we decided, and it's also part of our DNA, also not to show up in a very, brilliant manner and to make only announcement. Also, we want and we need to be consistent and to be serious, to have really a paved path onwards and not only some intention. So, I mentioned in the speech today that it was decided around about 2 years ago to move onwards to full circularity. 3 months ago, we announced the way and the goal regarding Scope 1 and Scope 2, and we want to achieve carbon neutrality in 2035. So regarding Scope 3, it's already in our mind, in our thoughts, but we need still a bit of time to document and to be sure of the right KPI we will take into account. So I can tell you today that regarding Scope 3, we will publish our objectives until end of next year, until end of 23. Scope 3, in our case, also we are in a pure B2B business, and what our customers and the end user, so the customers of our customers, do and intend to do with their products is not so transparent. We have no direct control, no influence directly on that, and therefore we have to discuss with all involved stakeholders to realize and to be sure, to be on the safe side, which KPIs, which performance factors we will consider to have a clear target on Scope 3.
Thank you.
Miriam,
Yes.
not meaning to put Francois on the spot. What percentage of your overall footprint is in your supply chain? 60%?
No, it's a bit less. I have not a precise figure in mind, but I would pretend somewhere around 40 to 45%.
So close to half of it is in your supply chain. So I'm going to make an appeal to you on the behalf of all of us. We have got to halve global emissions by the end of the decade. You won't be starting your program until almost halfway through this decade. We need to move faster. I don't mean to be at all rude or anything, but we need to move faster. It is just not good enough for any of us in this room to think that we can put this off and it's all magically going to happen in the last 5 years of this decade. And if we don't turn the corner, by the end of this decade, we are really in problems. So please, we have to move forward. Data is good, but you need to start engaging those suppliers earlier and building the right habits and getting them moving so that when you do collect data from them, it's really high quality data. You can act on it and make a difference, because I'm sure you can. Sorry for putting it, but it's late otherwise.
No, I take into account, and I will forward your comment internally at the right level. Yeah.
Thank you. There is a question for you, Per, about the heavy metals in wastewaters.
Yes, what we have done is that we have a process where we can separate out the heavy metals. And we have 2 different innovation companies that we own. Easy Mining is one of those, and that's the process I demonstrated here. What we do is that we make sure that we incinerate the sewage sludge, and after incineration you have an ash, and we are specialists in separating out of the ashes, separate the different elements, and the heavy metals will be definitely separated, and then it will become metal, metal pool of just metals, and that we have now a collaboration with a smelter that will use that and replace, in this case, a virgin ore. So they can use a little bit less of ore from their copper mine and replace with this one in that. And when we talk about our end product, we can't even detect any cadmium in the final product. And that's unique, I would say, in all processes what I've seen in the world. But if the one that asked the question, you can come forward afterwards, we can discuss that. In our other innovation company that also based on chemistry, we have a selective circular process where we can select the metals that we should extract from the wastewater. And we are a specialist in extracting, as an example, uranium. Uranium as a way of taking out the uranium, but we are doing it in a way where they can also be a way of mining the uranium. And then, of course, we can replace also the dependency of Russia a little bit.
Thank you. Is our society ready for circular economy? Are we there? Is there some behaviors that we need to shift? So who would like to answer?
I would say that the key component, my background is as Director of Human Resources. And that's the way I first developed on my thinking when it comes to sustainability development. And it's about changing behavior. And the key component here is to understand the ability to collaborate. And everybody talks about collaboration, but I need to see it happen for real. So what we are doing in our company is that we educate our managers and create leaders that has higher self-awareness, better self-esteem. But the importance more is to make sure that they really are confident in themselves, and then they can really start really open up for the challenges and talk with other companies and start this process. So I think that the key component going forward is the leadership, from our top management, but also the ability to collaborate.
If I can build on what Paul was saying, your question is society ready? And I think we have to break down the notion of society as something homogeneous and ask, are there necessarily parts of society ready that we need to get to a tipping point so we can fundamentally change the nature of production and consumption? And I think in industrial ecosystems, Par clearly is demonstrating, and I think Francois does as well, that we are getting close to a point where the competitive advantage and opportunity that we can get from reconsidering waste as resource is so obvious and so compelling that that is going to happen. I think that when we talk about consumer society, when we talk about consumer behaviors, it's much more difficult because we haven't yet made it easy for consumers to be part of the reverse logistics. I mean, that's what we're asking consumers to be. The question came up earlier about reverse logistics. We haven't yet made it easy for them to be part of the reverse logistics, and there is no obvious economic advantage for them for doing it. So I think we've got a lot more work to do amongst consumers as a whole to make it so simple. And all the evidence I've seen suggests that if it is made easy for consumers, consumers will do their part in the reverse logistics chain that we need them to be part of. But we consistently across Europe just put barriers in the way from consumers to being able to do it. I don't know if not. Peggy, you were nodding, or?
Yeah, no. Yes, I think that consumer is part of the solution, but as a consumer, he has to less consume in some cases, and we didn't talk so much about sobriety, but this is part of the solution. But also, he is part of the action to recover, to send it back the product to the right producer, who will be able to transform the product with keeping as much as possible of its value. So, but today we have to be clear, it's not very easy for a consumer to estimate the value inside its product. The material value, the functional value, the other value, and so we probably need to develop more this concept of product value at the end of life. The only thing is that for companies is that once the consumer knows the value of its product, if you recover it and if you obtain benefits about it, you want to share the benefits of it. We did some studies with economists, and for example, people are kind on putting more money for recycling because they know that recycling is necessary because you have pollutants, things like this. But when we talked about remanufacturing, they said, what is this? And when they understood that there was some value inside their product, they said, okay, we want to share the benefits of it. So it's also a change in the mind of companies, but also consumer, but also companies.
And I think we've got a long way to go in designing into products and services circularity. There's a lot more to be done. Much more creativity is required in, from the outset, designing in circularity. I mean, we have some product areas where we have incredible circularity already. I mean, if you take cars, cars get reused 3 or 4 times. And then about 80 or 90% of cars are either remanufactured at the end of life or recycled. So we've got some areas where there is very high levels already, but vast areas of our supply chains are built on this kind of linear process, and there's not enough creative thought going into designing in circularity at this point.
Miriam?
And the easiest way to change the supply chain the society has the key. It's public procurement. If public procurement could require circular material flows in much higher extent, it will happen automatically. Of course, all procurement need to be circular, but here that would be the lowest cost to implement a circular economy for the society.
Yeah, I just wanted to add something, is that when you ask a company, we were working with a company producing electric vehicle batteries, and we said, okay, perhaps it could be good to imagine from the start how to design some things that can be reused or to prolong the life of your electric vehicle batteries. And they say, okay, but we are just putting some investment on the new linear systems. We put a lot of money on this to be able to transform the industry, and so we don't have the money and time. So it's complicated for them to develop both systems. So in 2005, I said in my mind, okay, European directives are not so useful for things, but 15 years later, I said, hopefully they were there. So I said, now perhaps it could be good to have some regulation on circularity for companies, because perhaps in 10 years, or I hope as soon as possible, we will have real effect on this in companies.
Par makes a really good point about the procurement function in our programs, and what we're running around 20-odd global supply chain decarbonization programs at the moment. I can directly compare the most successful ones to the least successful. And the biggest difference is who owns it. The successful ones are owned by the chief procurement officer owns the program. And when it really works well, you have a sort of center of excellence or a working group, which is a combination of the sustainability team and the procurement team, and they set the strategy and the goals, and they make everything work. In the industrial ecosystem of the value chain, if procurement isn't driving the change, it doesn't happen. It's absolutely right.
Thank you. Any other insight or comment, or how you see your companies in the coming years coming from a big chemical industry?
I can very spontaneously confirm also what was stressed by Martin just seconds ago about the key role of procurement organization in a company, whether small, mid-size or big.
Yes. Thank you. I think we have taken a journey to new countries in the circular economy world this afternoon. Thank you for fresh, new example. I hope that you appreciated the fact that all these examples were really genuine. We are not talking about the same circular economy examples that we are used to hear about. Here it was really the innovation of today, capitalizing on all the lessons learned and all the ambitions of companies who are really engaged towards circular economy. And this example shows that there is no limit to what we can redesign to make it circular. Thank you very much. It was a pleasure to have you with us during this panel discussion. A big applause to our speakers. Thank you.
Thank you, Mary.
So I think you have the possibility to attend other sessions. Now there are 4 other sessions, so we have a quick move to other tables. I will be chairing another session, so if you want to continue the journey to sustainable development and new technologies, we will talk about the bio-inspired materials and processes and technologies.